Whenever I was in physics and I learned about work done by a force, it always kind of scared me. I always found it kind of to be a weird concept. But try to keep it as simple as possible to the simplest situations. Okay, I'm standing here holding my calculator. What work am I doing against gravity? Zero. Even though I'm standing here and after a long time I could get tired. I'm still not doing any work against gravity. I am applying a force to the calculator upward against gravity because gravity is doing a downward force. I am counteracting that by holding it here, but I'm not actually moving it, so I'm not doing any work against gravity. If I now move it, say, half a meter, that force that I applied does do work against gravity. How much work? Work done by a force in a certain direction that's parallel to the force is the force times the distance, F times d. You might also know that if you allow for a higher dimensional motion and F not necessarily parallel to d, that these things become vectors and this times becomes something called a dot product, but for Calc 2, we don't need to know that. Pretend F is in the same direction as d. The force is in the same direction as the motion, and this is an ordinary multiplication of numbers. What are units here? This would be in newtons, which I like to write with a capital N, but the book writes an NT lowercase. Either way is okay. This would be a distance in meters. In meters. So the product, it would be in Newton meters. Newtons times meters. What's the more famous name for that unit? Joules. Joules, or just J, is the unit of work. And you might also know joules is a unit of energy. So work is related to energy. But again, it's a little confusing because, again, like if I just stand here, I'm not doing any work, but I am getting tired if I stand here for 2 hours. Right? I'd probably eventually drop it because I get so tired. My body's expending energy, and then there are other ways, and I'm just holding it there. This is a more technical definition of work done by a force. It's useful for solving problems. That's why it's introduced in physics classes. And if I am applying that force to this mass to move it up by, say, half a meter, I'm doing work against gravity. The force would be the mass times the acceleration due to gravity. If it's against gravity. If against gravity. What's the mass of the calculator? I don't know. 0.1 kilograms. Let's just pretend. Say 0.1 kilograms times 9.8 meters per second squared times the distance was 0.5 meters. And yes, by the way, kilograms times meters per second squared, that is the same as newtons. This would be 0.98 newtons. 0.98 times 0.5 would be 0.49. 0.49 joules is effectively the energy that went into moving this up by a half a meter.